Okay, here's a problem from chapter 5.5, I believe. Um, it's a probability question. You have a test to determine whether an antibody is present, and it's 99% effective in recognizing it. This means that you will accurately determine whether somebody has it with a 99.7% probability. The probability of test coming back positive when the antibody is not present, a false positive, is less than 1%, right? Is 0.3%. Suppose the test is given to 5 randomly selected people who do not have the antibody, right? Um, so what is the probability that the test comes back negative for all 5 people? And remember, these people don't have the antibody, right? So if the test is accurate, it should come back negative. So in that situation, um, the test is accurately predicted. So the percent for each of the individual people is 99, I should say 0.997, right? The probability that each individual one is. And they're all, the test is independent of each other. You know, the one use of the test on one person doesn't really affect the probability that it accurately predicts the antibody's presence in another person. So all we have to do here is just, we have 5 different situations in which we have a 99.7%. We're just going to multiply the probability of each of those situations by each other. And I just do this a lot of times on Google. That's 99.7%. And I'm going to raise it to the 5th power. Okay, so this is what I would get. I would get 0.985. I'd have a 98% chance of predicting all 5 of them correctly. Okay, and we need to round to 4 decimal places. So that would be 1 there. Okay, so check our answer. Fantastic. So what is the probability that that test comes back with at least 1 positive, right? And remember, all these people don't have the antibody, so that positive is really a false positive. So that's, you know, there's a lot of different situations that could happen there. You know, one of the people has a false positive. You have 2 people that have a false positive, 3 people that have a false positive. And so we could calculate the probabilities in all those different circumstances, say with the binomial distribution calculator. But it's really easiest here just to recognize that all those situations are the opposite of all the other things that could happen besides getting 5 negatives, getting 5 good predictions. So really, part B is just going to be the complement of part A. It's everything else that could happen, so its probability has to be the opposite of part A. So I can go back to my little tab here and just write 1 minus this probability, and I get about a 1% chance of having at least 1 false positive. Oops. Sorry. There it is. Okay. Sorry about that. And we went around to 4 decimal places again. So it's, I think that's right. Let's check our answer. All right. We did it. So I hope that helps a little bit, right? You just multiply the probability of each person individually having the correct read, and you do that 5 times.